you send me the email.
Sir, same reason. Same only.
Okay, so you have sent it where? To the Learnivio team.
What's up?
Oh, so you have the same reason.
Yes.
Oh, okay. Then what can we do that? So what can we do, guys? Okay. Yeah, so this is a legitimate reason, right? Okay, so let us try to solve this right now. And then we'll learn about this addition of vectors in some other form. Okay. Yeah, so in the Rishita and Afaf class, we learned about the representation of vectors in this unit vector form, right? So Rishita and Afaf, you guys know that, right? And
Yes, sir.
and then from these representation of vectors, we can calculate what is the ultimate goal of the vector. We can calculate the magnitude and we can calculate the direction, right, guys? So we have this question where A is this, B and C, D are given. And we have to find the magnitude of this vector, which is combination of these vectors. Okay. So first, let us find out what is 5. Right. So let us do this problem here, and then we will proceed to the another problem. We don't know about the other problem. Yeah. So 5B. Right. B is this. So 5B would be how much? Okay.
20 I cap
Yes.
plus 15 J cap
Right.
plus 10 K cap.
So this is 5B and we have 2C. So Nabila, what would be 2C?
Uh, 6 I cap.
Yes.
Minus 8 J cap
Yes.
plus 2 K cap.
Okay. Correct. And so we have only one. So alpha, what would be, oh, D. So what would be 3D? Yes. Alpha, what would be 3D? D is here. Yeah, maybe you might be.
6 I cap
Yeah, 6 I cap.
plus 21 J cap.
21. Right. Yes, so that is correct. We have to find these 5B, 2C, and 3D and just plug in these values in here. Right. So S would be how much, Rishika? S would be how much? Yes.
Sir, 2
Yes.
I cap plus 4 J cap minus 3 K cap
Yes.
plus 20 I cap plus 15 J cap plus 10 K cap
Yeah, so this is a long one, right? So let me write
plus
that.
6 I cap minus 8 J cap plus 2 K cap
And
minus
yeah.
minus 6 I cap minus sir, this is supposed to be minus,
Yeah, because this is minus 3, right?
yeah, minus 21 J cap.
Yes, you were correct. Why were you hesitating, right? So you were correct. Yeah, so this is, so this is a vector sum, so I adds with I, right? This is not an algebraic sum. So, oh, so 6I cancels. And we have what? This is A, right? And 2I, 20I, and we have another I. So so this is 22I. Right, and 4J, and then 15J, and minus 8J, and minus 21. So minus 29, and then this is 24. So 24 minus 29 is how much? Minus 5J. Right, guys?
Yes, sir.
Minus 5J, and this is 3K, and this is 10K, so 7K, and then plus 2K, which is 9K, and then 9K. So this is S vector. Okay. And what would be the magnitude of this vector, Rishita? What would be the magnitude? Just
Vector by
no, vector by not the direction part, only the magnitude part.
a vector into direction.
So vector into direction. So you are saying that this is some vector into some direction. This is the magnitude. Okay, so no worries. No worries about the right? So this would be, so if you have this AXI vector and then AYJ, J component, Y component, and then the Z component. Right, so let's say this is the vector. So what is the magnitude, Nabila, of this vector? Or you can also represent that. What is this magnitude? Yes, Nabila. You have also forgotten. Okay, then Akif, what would be the magnitude here?
Sir, we have to take root.
Yeah, you talk.
This 22
Yes.
whole square.
So from here, this would be, yeah, correct. You are, so from that question, this would be root of 22. So now, Rishita, Nabila, do you guys remember? Okay, guys, so remember now.
Yes, sir.
Yeah. So this would go, okay, so this is a very,
Yes, sir.
huge number, so I don't know. So let's try to find, right? So you guys find out, and so this would be the magnitude, right? So this was the question that we are given some vectors, A, B, C, and this S vector was the combination of these vectors. So we calculated, and then we can find out the value of this vector. Okay. And what would be the direction of this vector? Afar. Yes, the direction of this vector would be how much afar? You have this magnitude and you have this vector. So what would be the direction? Afar, remember or what?
Sir, I don't remember it.
So revise guys, right? Yes, Akif sir, what is the direction?
Sir, I am not sir, you are sir, right?
Yeah, but okay. Yeah, so what is the direction, Akif? So whenever
Direction.
who is whoever is replying the answer, right? So that is teacher. So in that way you are a teacher, right? So okay, I can call you sir, right? Yeah. So what is the direction, Akif?
S no to say it.
Vector, right? This
Vector. Yeah, vector by
Yeah,
magnitude.
yeah. So this is how you calculate the direction. Right, Afaf and Rishita.
Yes, sir.
So
Yes,
we
sir.
now, yeah, so we know that S vector is 22I minus 5J plus 9K. And whatever is this variable. Yes. Okay. So this is the direction. So now we know much about the vector and this direction in this unit vector form, right? So as I was, as you guys, as was my first question, that if you guys move in the x direction, so that would be I hat, and if you guys move in the y direction, so that would be j hat, and if you guys move in the, let's say, z direction, so that would be k hat. Yes, yes, G, did you ask anything, Nabila? Yes, Nabila, did you ask anything?
No, sir.
Oh, so Afa was asking.
No, sir, I was just answering.
Okay, okay. Then. Yeah, so this part now we can understand, right? So I hope that you guys understand this. Okay, so what happens? So you guys see that So if whenever you are given this kind of form, right? So whenever you are given this kind of form, then you can add or subtract easily. As we saw in this case, right? So these were some vectors. So these were some vectors and we added them and subtracted them very easily, right? Just following the vector stuff.
Yes,
But
sir.
yeah, so but in the second scenario, what happens is that you are not so you are not given in this form. You are not given the universal unit vector form or the Cartesian form. So then we have to do one. So let's say you are given two vectors, right? Like this. Only the magnitudes are given. So this is some vector A and the vector B. And the magnitude of A is, let's say, A, right? And the magnitude of B is B. Okay. And the angle between them is B, right? So now how can we add these vectors? This will be my goal to teach in this class. Okay. Yes, so we have to, so for this case, we have to apply, we can do this by applying these two conditions. One would be the parallelogram law. So we have to follow this law. Or the other way would be the triangle law. Okay. So for the first, let us understand about this parallelogram, right? So whenever we are given two vectors and the angle between them, right? So then to add these vectors, right? So to add these vectors, we need parallelograms. Right. So what is the condition for this parallelograms? The condition is that the vectors have to be co-initial, right?
Yes, sir.
So this is the condition for the parallelograms, right? And we have to know about this angle. So there is some angle that we have. Okay. And we have to measure the angle with the tails of these two vectors. So we measure the angle with the tails of two vectors. So if it is given like this, right? Let's say it is given like, let's say this one. Okay. So, so this is this, so this one. Right. So this would not be the angle. Let me draw it like this. So this would not be the angle, right? This would not be the angle. Only we can measure the angle between the two tails. Okay, they are co-initial, and this has to be the two tails. Understood, guys? So this will be the angle between those two vectors.
Yes, sir.
Yes, sir.
Okay. Now let us understand how can we use this parallelogram form. First, we have to fulfill this condition. The vectors has to be co-initial. Right. So Rishida and Afa, you were not present in the yesterday class. So the co-initial meaning that they have the same starting point. Right. These two vectors have the same starting point. So let's say that you have these vectors. So these are not co-initial vectors. Okay, Rishida and Afa. The vectors
Yes,
have to be the same starting point. Okay. So this is what do I mean by this co-initial vectors. Understood? Now we have to find what is A plus B. Right, this is R. And let's say this is R. So R is A plus B. And we have to find what is the magnitude of R and what is the magnitude of R and what is the direction of the R. Okay. So this is called the resultant of the vector. Okay. Understood, guys?
Yes, sir.
And the idea is that we have to make the parallelogram. So as the name suggests, we have to make the parallelogram. Okay.
Yes, sir.
So can you repeat again?
Yeah. So the idea is that to apply this parallelograms law, as this name suggests, we have to make a parallelogram. Parallelogram, right? So the geometry would be a parallelogram. Understood?
Yes, sir.
So let me draw the geometrical representation of this parallelogram. Right? You have these vectors. This is A. This is B. Right. So to make the parallelogram, we have to draw a parallel at this point, which is equal in the equal vector of this B part. So at here we have to draw the equal vector of B. Right. So this would be the same angle and the same length. So this would be. So this is B. Right. And again, at this point, we have to draw the parallel of. So this is. Now you guys can see that this is a parallelogram, right?
Yes, sir.
And whatever is the diagonal. So whatever is the diagonal, this will represent the result, which would be A plus B. Okay. So this is
Yes, sir.
this is the geometrical representation of a parallelogram. Understood, guys?
Yes, sir.
And to find out the value, yeah, and to find out the value of the magnitude, we have to draw some extra construction. Okay, so this is the parallelogram, right? Okay, this is not a parallelogram. Okay, and we have to draw a perpendicular at this point. And this is our final diagram. So this is the result, right? This is R. This is the magnitude. And what is the magnitude up to this point, guys? What is the magnitude? What is the length of this vector? What is the length of this vector, guys? Okay.
Sorry, sir. Which?
Yeah, so this is vector A, and what would be the length of this vector? The magnitude, right? Yeah.
Magnitude by direction?
No. So I'm asking about this length will represent the magnitude, right?
Yes, sir.
So this is how much? This part, length part. A,
It
right?
will be
Right. And this is, so this was some angle theta. This was some angle theta. And we are drawing a parallel. So this would be how much?
same.
Same theta, right? Corresponding angles.
Yes, sir.
So this is theta. Okay. And okay, so and this is how much? This length is how much? This length is how much? This length.
Vector V.
No, I'm only asking about this length.
Direction?
B.
Length, yeah, B, yes. Okay. Just so we have to find the magnitude on. So just forget about the vector part for the time. Okay.
Yes, sir.
Yeah, so this is B, this is theta, and this is A, and this is R. Okay. So let us say that this is A, B, C, D parallelogram, and this is N. Okay. So we have to find this length first and this length first. Right. And then we can find out. So if we know this length, let's say this is X, this is Y. Right. this is y. So then we have this diagram. A plus x, and this is y. Right, then we can apply the Pythagoras theorem.
Yes, sir.
Right, so this would be our aim to find this x and this y. Understood, guys?
Yes, sir.
Yeah, so just remember the trigonometric part. So can you guys tell me, this is the 90-degree angle. Okay, and what is the side which is opposite to this 90 angle?
A.
A,
B, 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 B.
B. Yeah,
Opposite.
so opposite to 90-degree is B. So this will be what? This would be hypotenuse, right?
Hypotenuse.
So this is hypotenuse. Okay, and whatever is this angle making, so the hypotenuse and this angle, so whatever is the second side, this is called what? So you make the angle
Base.
with, yeah, base. So this is the base, right? X is base. Okay, and the opposite to this angle is what? Perpendicular, right? What is the image? So this is perpendicular. Okay, now you guys tell me what relates the base with the hypotenuse. We have, so our aim is to find this x and find this y. So this is our aim. Okay, guys. So you guys tell me what
Tan
relates.
theta.
No. What relates base with the hypotenuse? Yeah. So Akib answer is tan theta.
Yes, sir.
Yeah. So Akib. And yeah. So Nabila, what is your answer? What relates base
Cos
with the
theta.
cos theta? Okay. So Nabila cos theta. And Afaf, what relates base with the hypotenuse? Just remember the trigonometric ratio. Afaf, are you there? Maybe your voice is
Tan.
10. 10.
Base by hypotenuse. Yes,
Yeah.
I'm right.
Yeah. So what is that?
The right of adjacent
adjacent
and
by
opposite.
Yes.
adjacent by cos. It will
Cos.
be adjust.
Yeah. So Afaf answer is cos. Okay. And Rishita, what is your answer?
Cos theta, sir.
Yeah. So majority wins, right? Okay.
Yes, sir.
Yeah. So cos theta would be base, which is x, by hypotenuse, which is b. So x would be how much? Our goal is to find x and y. Just remember this, right? So x would be b cos theta. Right, guys?
Sir, instead of doing this much, we can just take tan theta, right? What will the value of tan theta? We'll substitute and we'll get x and y. Because tan theta's
Okay.
value is opposite by adjacent, right?
Yeah. So you have x and y unknowns, right?
Yes, sir.
And you know theta and b. These are two unknowns, right? So you have
Yes,
to
sir.
write your unknowns to the form of knowns. So if I write tan theta, so tan theta would be, let's say, y by x, right? So y
Yes,
would
sir.
be x tan theta, right?
Yes, sir.
So you have this unknown and this unknown, and you have only one, right? But you want to find these two unknowns separately,
Okay.
right? Okay, did you understand this part?
Yes, sir.
Yeah, because we know b, we know magnitude of b, we know from here. So this would be given. For the addition of vectors, this would be given, this would be given, and theta would be given. So we know A, We know B and we know theta. This is the known part. Okay. And we have to write all our equation, all our anything in the form of A, B, and theta. Right, Apple?
Yes, sir.
Yeah. So that is why we are calculating in the form of this B cos theta and psi. Yeah. So the next question, what relates this perpendicular? Okay, so this is obvious question you guys know, so you need to ask, right? This would be y by b. So b and y would be b sine theta. Right, guys? Understood?
Yes. Sir.
Okay, so we have to find the magnitude of this resultant. This is the magnitude, right? And now we know this x. So x is b cos theta, and y is b sine. Right. So r would be how much? R would be how much, guys? Pythagoras theorem, right? R would be how much? Yes, perpendicular base. No hesitation, guys. Please, so without any hesitation, whether the answer is wrong, correct, don't think about that. Just tell me what is coming into it. Yeah, Rishita, what would be this R from the Pythagoras theorem?
Root of b sine theta plus by p whole square.
No, this is not by P. I am writing this. This is perpendicular, right? So
And
this
base.
is
Yeah, okay.
oh,
Root
this-
of b sine theta whole square
right.
plus a plus b cos theta whole square.
So this would be A plus B cos theta. Yes. Are we correct, guys? Nabila. Is this correct? Yes.
Yes.
Okay. Yeah. So let us solve this part. So this would give us the magnitude of this resultant vector, right? So this is b sine square theta is b sine square theta, and we have to apply this a plus b whole square, right? So that would be a square plus b square, and then 2. Okay, guys. So this would be, and you see that b square and b square is common. So let's take a square in this side, and b square would be common. So this would be sine square plus. So this identity you guys know, right?
Yes, sir.
So this is how much?
1.
1, right? So then this would become a square plus b square, and then 2ab cross theta. Okay, so this would be the magnitude of the two resultant vectors. Any question in that, guys?
No, sir.
Okay, yeah. So yeah, so you guys note down from them. Okay. Where should I put the screen? Yes. Okay. Or should I scroll down and then you guys? So any doubt, guys? Any doubt?
No, sir.
Okay. The idea is that we have to just apply the Pythagorean, right? And to apply the Pythagoras theorem, we have to just find out the missing values. We have to make the right angle triangle And so we have to do the extra construction and then just find out the item.
Yes, sir.
Okay, should I scroll down this part?
Yes, I have to scroll it down.
So Afaf has maths in her 11th. Akib has computer science or PCMs, right?
Yes, sir.
And so you two guys have maths. What about Nabila? Do you have maths? Nabila.
No, sir.
Okay, you don't have maths. And Rishita, do you have maths?
Yes, sir.
Okay. Okay, so for three of you guys, it would be not difficult to tell you about the inverse trigonometric function, right? But for Nabila, yeah. Okay, done guys up to this point. Should I scroll down this?
Yes, sir.
What about the rest?
Yes, sir. Done.
So this was easy, right?
Yes, sir.
So one task is done. We have calculated the magnitude of the resultant of two vectors, right? If the magnitude of two vectors is given and the angle between them is given. So this is called the polar form of the vectors, right? So if the polar form is given, then we have to calculate the magnitude like this, right? So we know, so you see the answer. In the answer, you have this magnitude of one vector, magnitude of second vector, and the angle between, right? Then you calculate the magnitude by this method. Okay, just remember in case of the this universal unit vector form, the R was like this. This was ax squared plus by plus by squared plus z squared. Right. But for this case, we have this result. Right, guys?
Yes, sir.
Yes, sir.
Yes.
Okay, done, guys.
Yes, sir.
Done.
Yeah. So now let us understand about this direction. Okay. So let's say that you have this vector. Right, you have these two vectors. And this angle movement. And you have this resultant, which is so this is the resultant. And the direction of this resultant is this. So you have to, for this case, you have to find the angle. So this is, okay, this is not. Yeah. So this resultant is making an angle, let's say alpha, from this vector T. So this to find out, right? So this is the direction of this R vector is at some angle alpha from this vector T. Understood?
Yes, sir.
So this is the direction of this resultant vector. So now what we have to find here, guys? What do we have to find? Yes, guys. What do we need to find? Which will tell the direction of the resultant. Yeah, this alpha, right?
Yes, sir.
This will tell the direction of this resultant vector. So this will tell that what angle it is making the resultant, at what angle this is present or making with the vector A, right? So we have to find this angle. And you guys remember the diagram, the effective right angle diagram. So this was the effective right angle diagram. This
Yes,
was
sir.
this was A plus B cos theta, right? This was,
Yes, sir.
and this is now the alpha, right?
Yes, sir.
And this was how much?
B sin theta.
B sine, correct. So you can now now you can calculate now your idea can be useful, right? So you can calculate now alpha, and that would be how much? So this would be how much? Tan alpha would be, right? Okay.
B sin theta
Yes,
whole divided by A plus cos theta.
yeah, absolutely right. Right, so this is the angle. Okay, and if you want to find out this angle, so this would be tan inverse, right? B sine theta and A plus B cos theta. Okay, so this is the angle that we need to find. So if in the question they ask about this direction, so the direction would be alpha angle with this vector A. Okay.
Yes, sir.
Yeah, so please note down this part and then I will tell about this inverse of this trigonometry.
Okay, sir.
So for Akib and Rishita and Afaf, this will be a repetition. You guys have learned this inverse trigonometric function, right? So that was the third chapter, I guess.
Sorry, sir.
So did you guys learn about this inverse trigonometric function in your 11th class? That is, I guess, the third chapter. Or is it in 12th?
Sir, I joined 2 days ago, so I didn't really
Oh,
learn anything. Yeah.
so good. Okay, so then I will. Okay, then I will. So then I will explain this more or more precisely. Yeah. So please note down this part, and then we will learn about this inverse trigonometric function. So only in this parallelograms law, what was the important part? This diagram is the most important part. So if we remember this diagram, then all our answer will be clear. So if we remember this diagram,
Yes, sir.
right, then we can calculate this magnitude, and then we can calculate this angle also. Okay, so just remember this diagram. If you know this parallelogram, also just remember this diagram. Okay, guys.
Finished, sir. Yes, sir.
Finished? Yeah. So let us understand about this inverse trigonometric function. Okay. So you have, you know this trigonometric function, right? You know sine theta, you know cos theta, you know all those sec theta, tan theta, right? So let's say you have this sine theta, which is let's say half, right? So if I take this sine theta in this part, so this sine is a function, right? This sine is a function which is operating on this angle. So if I
Yes,
take,
sir.
so if I take sine in this right hand side, so this would be theta, and this would be sine inverse. This would not be, let's say this sine into, this is not sine into theta, right? So if we take theta, this would not be 1/2 divided by this sine, right? Because this is not in multiplication. This is some operation, trigonometric operation, right, guys? So
Yes, sir.
if we take this in the right hand side, this will be inverse of this, right?
Yes, sir.
So this is telling what, that at what value of sine. So what is the meaning of this sine inverse 1/2, right? So the meaning of this sine inverse 1/2 is that at what value of sine theta you have this half value, right? What value of half gives your sine equals to, so what would be the value of theta which give the sine value half, right? So this is the meaning of this inverse. Understood, guys?
Yes, sir.
So what would be the theta here for this half value? So what is the value, or what is the value of theta which gives the value of sine theta as half? What would be that? What would be that value?
30.
Yes. So theta would be 30. Right. So if I ask you what is tan inverse √3? So what does it tell? It is telling that at what value of theta, your tan theta is √3. Right.
60.
Yeah. So this would be 60. Correct. So do you know inverse trigonometric function, right? Yeah. And okay, so let me ask Afaf and Nabila the question. So what would be cos of let's say √3/2? Nabila, what would be this?
45.
45. Then let me ask you this question. Question after question. What would be this? So first understand about the meaning of this question. This is saying that at what value of theta you get your cos theta to be √3/2. So what is the value of theta for which you get the value of your cos to be √3/2? What is that value of theta? Is it 45, or is it as Afaf is saying in the background?
30.
Yeah. So Nabila, understand?
Yes, sir.
Yeah. So this would be 30 or 45.
30.
30, right? And what would be this value?
45.
Yeah. Why are you hesitating? 45 is the right answer, right? For cos 45, we get 1/√, right? So if we take 45, this would be cos inverse 1/√. So this is about the inverse that we need in this vector part. So we don't need to know about more about this inverse trigonometric function. We only need this much, right? At what value of theta we get this value. So, okay, guys.
Yes, sir.
Yeah. So now we can do some questions. Right, we can now calculate. So if we are given the value of two vectors, the magnitude of two vectors, and if we are given the angle between them, then the ultimate purpose is that we can calculate the resultant with the magnitude of the resultant and the angle of the resultant made with the A vector or the base vector. Okay.
Yes,
So,
sir.
so let us do this question. You have these two forces, right? Let's say this is 4 Newton, and the magnitude of this force is 3, and this is 4 Newton. Okay. And we want to calculate what would be the resultant of these two vectors. So will it be 7 Newton? Will it be that? Huh?
Yes, sir.
Will this be, so this would be vector sum or this algebraic sum? These are two vectors, right?
Wait,
Right,
Vector sum?
Akhil?
Yes, sir.
So we need to find, let's say this is 60 degrees. We need to find the resultant of this vector, right? This should not be 3 plus 4, right?
Yes, sir.
So you know what is given. A is given. A is 3, B is 4, and theta is 2. Right. So the resultant of these two vectors would be this. This would be the resultant, right? Right, Akhil?
Yes, sir.
So we need to find R, and we need to find R. Understood?
Yes, sir.
Yeah, so Rishita, tell me what would be R?
So
Yes.
4 root of 4m square plus 3m square.
4
Root
square
of 4
plus
square,
3 square.
4 square plus 3 square. Yes, sir.
3 square. And nothing more.
Plus 2 into 3 into 4 cos theta. Cos theta 60 is 1
Yeah.
by 2.
Okay. Yeah, so okay. So will this be, is this the correct answer, Rishita? Or yeah. So is this correct, Rishita? Nabila, Akib, do you guys think this is correct?
Sir, we have to simplify more.
Okay. So is this, are we going in the right direction? So let me rephrase my question. Are we
Yes.
going? Yeah, so yes. So Rishita, to be not get confused with this. So if we had this and this is X and this is Y. So if we had a question like this, right, the angle would have been 90 degrees. So this would have been 3I and this would have been 4J. So you were thinking like this. So the vector would have been 3I plus 4J, and then the magnitude would have been, as you say, 3 square plus 4 square. So what are you thinking like this,
Yes, sir.
Rishita? Yes, Rishita.
Yes, sir. I was thinking like that.
Yeah, so this is not the case, right? Because if we don't know about this universal integral form, right? We don't know about this I. Okay, this is with some angle. This 4 is with some angle. Of course, 3n could be, we can write it as 3I, right? We can write 3n as 3I, but we don't know about this guy, 4n, right? So,
Yes, sir.
so we can apply this part, this parallelogram. If we know the magnitude of two vectors and the angle with, yes, did you say about anything?
The answer is root 37.
Okay, so you already calculated the answer. Okay, yeah, nice. So this is 16 plus 9 plus 12, and this is how much? 25, yeah, root 37. So this would be the magnitude of this result. And this is root 37. And we need to find this angle. Okay. Understood,
Yes.
guys? So we need to always do the vector sum. If we are given two vectors, so to add those vectors, we need to apply the vector sum, right? Always remember that this is vector sum, not the algebraic sum. Okay, so we have to see
Yes,
in the context of these magnitudes. Okay, guys.
Yes, sir.
Yes.
Yeah, what would be the angle? Guys, tell me, what would be the angle?
4
For
For what? For
sine
sine.
root 3 by 2.
Okay, so let us write this as 4 sine 60 by a, which is 3. Right, so
3
step by step.
plus, yes, sir. Plus 4 cos 60.
Right, so is it correct, Nabila, Afaf, and Ishra? Is it correct?
Yes, sir.
Yeah. So
Yes.
4 sine 60 is as Akib was saying, root 3 by 2. And then 3 plus 4 sine 60 is 5. So this 2 cancels and this 2 cancels, and we have 3 into 3 by 3 plus 3, which is 5. Right. So this would be tan alpha would be, this would be 2 root 3 by 5. So alpha would be tan inverse 2 root 3 by 5. And we don't know this value, right? So at what value of theta we get this value, we don't know. So we will keep our answer like this. Okay. So
Okay, sir.
so our final solution would be that magnitude is root 37, and direction is at an angle of tan inverse 230 by 5 with a, where with is with whatever we call with 3 meter. Right. So this would be the answer. Understood, guys?
Yes, sir.
Okay, so where was that question? Yeah, this was the question. And I have messed up this question, so you guys let me clear this for you. So this was the question. Yeah, so these three values were given, and we have to find the resultant. And so you guys please note down this part. And I will give you one question, and then I will discuss the next question. So any doubt up to this point? Just remember that we are learning vector calculus. So all those operations that we have done so far about this algebraic algebra, just forget about that. We have to very careful with this magnitude of these two vectors. Okay.
Yes, sir.
Yeah. So you see that at one time, right, we can only calculate the resultant of two vectors only. Okay. So from this Parallelogram's law, we can only calculate the resultant of two vectors. Understood. So this is the one thing about this parallelogram law.
Yes.
Yes, sir.
And one more thing to remember is that these two universal unit vector form is different, and this polar form is different. So whenever you are given in the form of polar form, then you use this Parallelogram's law. and addition and subtraction in the universal vector form is different. That is easy. So you use that. Okay.
Yes, sir.
So whenever you guys are finished noting, please tell me when I will scroll down.
Sir, can you say again what you said? Your voice was not audible to me.
Oh, so I was saying that whenever your vectors are given in the Cartesian form or the universal unit vector form, so you apply the addition criteria of that form. Okay, that is simple. I added with I and J added with J, or K added with K. But whenever you are given the two vectors in the polar form, meaning that you are given the magnitudes of two vectors and the angle between the two vectors. So then you have to apply this parallelogram. Okay. Then you calculate the magnitude of the resultant vector with the idea of this parallelogram. Understood about it? So always keep in mind.
Yes, sir, understood.
Yeah. So should I scroll down this screen?
Yes, you can scroll down.
Yeah. What about you, rest of you guys? What about you guys?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Written guys.
Yes, sir.
Yes, sir.
Okay, so we can write the direction in this way also. So this is north, this is south, this is east, and this is west. Okay, and the angle is this, and this is whatever is this angle, 2√3/5 times. So this is what direction, you guys? Can you guys tell me? This is what direction?
Northeast.
Northeast, right? So we can write this at an angle of 2√3 and northeast, right? So with the 3n, and we can also write this as or northeast, right? We can also write this. Understood, guys?
Yes, sir.
Yes, sir.
Yeah. So now let us do one more problem to get an idea of. So let's repeat the question, but with some modification. So let's say that this vector is, let's say again 3 Newton, and this is, let's say, let's write it as 2 Newton and then 3 Newton. These two forces are acting, and then you have the angle between them is 1 Newton. Right. So, yeah. So, okay, tell me what would be the resultant? Let me write it.
2 square
Yes.
plus 3 square
Yes.
plus 2 into 2 into 3 cos 120
Yes. correct.
60 into 60.
60 into 60.
60 plus 60, right? 60
no,
degree plus
so
60 degree, 120.
yeah, so that is 60 plus 60, but we calculate the angle of the cos above. So this lies in the second quadrant, right? 120 lies in the second quadrant. So do you guys remember the trigonometric
Sir, we can take one, right?
relation? So we cannot write cos 120 as how will you write? Cos 60 plus 60 we can write. Then after that, how will you proceed?
1 by 2 plus 1 by 2 is equal to 2 by 2 and then 1.
So you are saying that yeah, so what did you say? You are applying this cos A plus B formula.
No, sir.
Yeah, so then what are you saying?
Sir, cos 60 value is 1 by 2, right?
Yeah.
1 by 2 plus 1 by 2 is equal to 2 by 2. And if we simplify it, we'll get 1.
No, boss. That is not. So these. So this is some. So let us understand this. So this is some operation, right? This is not some multiplication, right? So this would not be cos 60 plus cos 60. Is this a multiplication? Not, no? This is not
Yes, sir.
common here, right? So
Yes, sir.
this would not be cos 60 plus cos 60. Okay,
Yes, sir.
either you can apply this formula, right? So this cos A plus B is cos A into cos B minus sin A into sin. Either you can apply this, but we know the trigonometric relation about this angle. So we know that we can write, so there is a general rule that we can follow. And that is what? So cos 120 would be cos 90 plus 30, right? So this would be cos 90 plus 30 would be sin 30, right? And what would be the sine of this? So the sine of this would be decided by this quadrant. You guys remember what I'm telling you guys? So do you guys remember?
Sir, I didn't understood this part. How
Okay.
sine came.
Yeah. So there is a trigonometric relation which says that if you have some larger angle, so this say, oh, maybe this was not in your 10th syllabus because this you learned in your 10th part. So yeah, so cos 90 plus theta is sine theta, and the sign is different. Okay, so you guys remember this. Let me remind you this. So cos 90 plus theta is how much? Do you remember this? Yes, okay. Cos 90 plus theta, you know, right?
Yes, sir.
So this is sine theta, right? And similarly, sine 90 minus theta is cos theta. Okay, so the cos changes to sine. Whenever you have this odd multiple of 90, so this cos changes to sine. So this is the rule. Okay.
Yes, sir.
And in first, so this is the first quadrant. So in first quadrant, all the trigonometric ratio are positive. And in second quadrant, only sine and cosec are positive. And in third, only tan and cot are positive. And in fourth, only cos and sec are positive. Okay. So do you guys remember this rule?
Yes, sir.
This is second quadrant, this is third. Yeah, so okay. So now if you remember that, then 90 plus 30 comes in which quadrant? So this lies in which quadrant? Okay.
Second quadrant, sir.
second quadrant, right? And in second quadrant, cos is negative. Only the sine and cosec are positive, right? So
Yes, sir.
this is 90, so cos would change to sine 30, right? And the sine would be plus or minus sine,
Minus, sir.
minus, right? So cos 120 would be minus of half. So you see that we were getting half plus 1, but that is 1. So this is totally opposite to this minus half, right? So
Yes,
this
sir.
is how you calculate cos 1. Yes, Nabila, Afaf, and Rishita understood this part.
Yes, sir.
Yes, sir.
Okay. Now you guys tell me what would be sec. Let's say 137. This would be how much? Yeah, you guys. So tell me, what is sec 137? Yes, guys.
Doing, sir.
Oh.
No idea, sir.
No idea. Get idea, 3G, right? Okay. Yeah, so this would be sec. And what about the rest of you guys? Nabila, Afaf, and Rishita?
Yes, sir.
No, sir.
No idea. Yeah, so this would be 90 plus 47, right?
Sir, how?
This would be,
This is a problem, sir. 47.
huh?
47 is a problem, sir.
47, we want to write it in the form of less than 90-degree angle, right? This is our problem. So, did you guys get confused with this 47?
Yes, sir.
Okay, so
So
my
we don't know
mistake.
the value of 47.
Yeah, we don't know, but this is, so I wanted this answer to be less than 90, right? So that is, okay, I didn't tell you about this angle. Okay, my mistake. Yeah, so let me correct this and yeah, so now I think that you guys, okay, how to change the angle.
Yes,
Okay,
sir.
so where were we? We now know what is cos 120, right? And this is minus half. Okay,
Yes, sir.
so this would be, yeah. So this would be minus half and plus 2 into 2 into 3 and minus half. So 2 will cancel and this would be 4 plus 9 and minus of how much? 6. Right. So this is 3 and 7. So this is the magnitude, right, guys?
Yes, sir.
And now you guys tell me what would be the direction. So please calculate and tell me what would be tan.
Okay, sir.
Any question, any doubt up to this point, guys?
No, sir. Sir, 3.
3.
Yeah.
Tan alpha is 3. And what about rest of you guys? So did you also get 3? Yes, half also got 3. Okay, so and Rishta and Nabila,
Yes, sir.
you also got 3.
Yes.
Okay, so if and Rishta, what about you? What did you get, Rishta? Rishita, yes. How much did you get, Rishita? Or you are still calculating? Or you got confused? What option will you choose?
Sir, can you hear me?
Yes, yes. You also got 3, or you got stuck at some point.
Sir,
Yeah, yeah, we can hear you. Yes, yes.
hello.
Yes, 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 we can hear you, Rishita. Yes. Am I audible, guys?
Sir,
Yes.
I don't think I can hear you.
So can you write it in the chat box? Your answer. Okay. So if she cannot hear me, then I have to write it in the chat box.
Sir,
Yes.
sir, can I leave the meeting and join again? I'll just
Okay. 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 Ishita. Yeah. 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 You can do that. Um, yes. Okay. I have message to Papa that I. Okay. So she left. Okay, yeah, so if the majority is telling that it is 3, then let's accept that this is 3. Okay. And then alpha would be how much, guys?
Tan power -1, 3.
Right, so tan inverse 3. So this would be the direction. Did Rishta, okay, so she did not. Yeah, so the answer would be that resultant is magnitude of the resultant is √7 and direction is at an angle of tan inverse 3 with 2 Newton force. Understood, guys?
Yes, sir.
Yeah. So let me again recap what we must follow or what we must remember. So if we are given the vectors in the Cartesian form, right? So or let's say the universal unit vector form. Right. So we have to apply, let's say this is I, J, K, then just apply the addition rule of that. I with I, J with J, and like that. So this is how we do the addition, right? And then we find the magnitude with or whatever is Rx or that. So this we find like that. And the direction is R vector by. So this is in the Cartesian form, right? And then we have this polar form. So in polar form, we are given the magnitude of 2 vectors and then the angle. So we apply the parallelogram law. Right. And in parallelograms law, we find the magnitude as this. And the angle is this. Okay, so this we must remember. Understood, guys?
Yes, sir.
Yes, sir.
Oh, yeah. So, okay. Afaf, so you also can't hear my voice. Am I not clear, Akib and Nabila?
Now, sir, I can.
Yes, sir.
Oh, okay, okay. So this message was meant for Rishita, but she left and then your name came up, so this was sent to you, right? Okay. Yeah. So let us do one more problem, right? We have 5 minutes left. So this is a question which says that if the magnitudes of two vectors are equal and the resultant of these two and the magnitude of the resultant of these vector is also equal to the magnitude of one vector, then find the angle between the vectors. Okay. Find the angle between the vectors and also the angle between the resultant and the vector. One. Understood, guys?
Yes, sir.
So magnitudes are given and which are equal. So and all there's also this condition that whatever the resultant of these two vectors, so that magnitude is also equal to these magnitude. So this is the condition that is given. And then we have to find whatever is the angle between these two vectors. So what is given? A is given, B is given, and R is given. Right? And we have to find what? Okay, so did Vishita join? Okay. Yeah, so and then we have to find what? Yes, Afa, we have to find what? Can you guess?
You have to find the angles of the vectors between them.
Theta we have to find, right?
Theta.
And alpha also. So these two we need to find. Okay. And what is this condition given? So two vectors are equal. The magnitude of two vectors are equal. So let's say A equals to B, right? And the magnitude of the resultant of these vectors is also equal. So this is also equal to R. Right?
Yes, sir.
Yes, sir.
Let's say this is some M. Okay. The magnitude is M. Understood, guys?
Yes, sir.
So what is R? What is R, Nabila? Yes. What is R, Nabila? Magnitude of the resultant. What is this?
So,
Yes, you did that question just just a moment ago. What is the magnitude of this resultant in parallelogram law?
A square
Yeah, yeah.
plus 2ab
Yeah.
cos theta.
So why did you take so? Yeah. So this is the
My confusion.
Yeah, yeah. So okay. Okay. So that is why I'm in, right. So this is 2ab cos theta. Right. And we know that R is M. Right. A is M and B is M. Right, guys?
Yes,
Yes,
sir.
sir.
Yeah. So did Rishika join? Okay, she has started. So M would be. Oh, so did you guys note down this question?
Yes, sir.
Okay. Yeah. So this is 2m square and then m 2m square cos theta. So this would be m square, which is let us square in both the sides. Okay. So squaring both the sides, we would get so this would be m square and this is 2m square plus 2m square cos theta. So what is common here?
2m square.
2m square is common and this is 1 plus cos theta. Right, so this is m square and if you take 2m square in the left hand side, so this would be m square divided by 2m square and this is 1 plus cos theta. Right, so m square cancels and we have 1 by 2 minus 1 is cos theta. So cos theta is how much? Half minus 1, this is minus half. And you guys just have calculated what is this theta for minus half. So this would be 120. Right, guys?
Yes, sir.
Okay, so let us stop at this point and just you guys. So just note down this part. Any question or any doubt in this question?
No, sir.
Nabila and Afaf, any doubt?
No, sir.
So I wanted to give you guys some homework, but we don't have time. So, yeah, so I think that when the class would be okay, who left again? Afaf left, right? Yeah, Afaf left. So Afaf connection problem again.
Sir, your voice is not audible. It's getting break in between.
So now can you hear me?
Yes, sir. Now I can hear.
Yeah. So do you have any doubt in this question?
Till m equals to on the road, I don't have.
Okay. So you got disconnected at this point. M equals to root of this.
Yes, sir.
Okay. So these magnitude is all these magnitudes are equal, right? So A equals to B equals to R. So either we can write in place of R A. So we could have done this also. So in place of R we can write A, and in place of B we can also write A. Right. So this would be A into A. So either we can write it like this or we can compare with this number n. Right. Understood this point?
Yes, sir. Now I understand.
So then we solve this part. So then the next part is solving. Okay, so just just note down this part and any more question you have. Yes, Afa.
No questions.
Yeah, so whenever you guys are finished shooting, tell me then just go now.
Done.
Done. Yeah, what about Akib and Nabila? Done.
Finished, sir.
Oh, you already finished. Okay.
Yes, sir.
Yeah, maybe where is Rishita? Okay, so I don't know if she will be joining after because if this class is over and then she tries to join then. Okay. So we are doing the addition in the coded form. Then we will do the subtraction, multiplication, and then we'll start with this second chapter. Or the first chapter is easy, so I will start with this first chapter. Okay, guys.
Yes, sir.